Welcome to Simplilearn. In this video, we will see what is data science, need of data science, skills in data science, data preparation for data science. So before we begin, consider subscribing to Simplilearn and hit the bell icon to never miss any updates from us.
Now, you must have already heard about autonomous cars. So I'm sure you must be excited to have a car driving by itself, which will take you from home to office or office to home, right? And that's where one of the examples where data science is used. Now, the car needs to take a lot of decisions in this whole process, whether to speed up, whether to apply the brake, take a left turn, right turn, or slow down. So all these decisions are basically a part of data science. And there is a study that says that self-driving cars will minimize accidents, and in fact, it will root out more than 2 million deaths caused by car accidents annually. Self-driving cars, right now, there's a lot of research and there is a lot of testing going on, and not a lot of cars are yet in production in terms of usage, but it's going to happen. Every automotive company worth its name is investing in self-driving cars. So in about 10 to 15 years, some of the studies say that most of the cars will be autonomous or self-driving cars. Where else there are issues? For example, if we take airlines, this is another area where data science contributes in a big major way. Flights get delayed due to weather conditions because the weather is not predicted in time and the demand of passengers is not probably seen ahead of time. For all these, you need data science. Then this could be improper route planning, and some customers might miss some flights. That again needs data science. And similarly, it could be incorrect decisions in selecting the right equipment. So which plane should fly in which route? That's the equipment that's being mentioned here. If that is not planned properly, then you might end up in a situation where the plane is not available, whereas you have planned for a flight in a particular route. So these are some of the challenges in one of the representative industries we are talking about, which is airlines. So if we use data science properly, all of these or most of these problems can be avoided, and that will help in reducing the pain both for the airlines and also for the passengers. A few more examples. What else can we do? Here are some of the other things that we can do, and we will stick to the airline industry. We can do better route planning so that there are less cancellations and less frustrated people. We can use predictive analytics and predict any delays that are there so that some flights can be rescheduled ahead of time and there are no last minute changes. Data science can also be used to make promotional offers. And the last but not least is what kind of planes should be used, or the different classes of planes that should be used in different routes for better performance. So these are some examples of how data science can be used in airlines. And another example or another industry where data science can be used and benefited would be in logistics. So companies like FedEx, they use data science models to increase their efficiency drastically, to optimize the routes and cut costs and so on. So before their delivery truck actually sets out, they determine which is the best possible route to ship their items to the customers. And based on various inputs, they also predict or come up with the best suited time to deliver. And last but not least, they determine what is the best mode of transport for this delivery as well. So what is data science used for? These are some of the main areas where data science is used. For better decision making, there are always tricky decisions to be made. So which is the right decision, which way to go? So that is one area. Then for predicting, so for performing predictive analysis, like for example, can we predict delays like in the case of airlines? Can we predict the demand for certain products, let's say in e-commerce? That is the second area. The third area is pattern discovery or pattern recognition. Is there a pattern in which people are buying items? For example, it could be seasonality. If you take the data, sales data for multiple years, there may be a pattern in the way people are buying. That's a buying pattern. In certain months, probably the sales will increase. Certain months, the sales will come down. Certain quarters, traditionally, the sales will be higher. Certain quarters. So that is a pattern. And this pattern discovery is another area where data science is applied. So what is data science? Now, let's take an example, a real life example. On a day-to-day basis, we use or we try to make some decisions. Let's say we want to buy some furniture online for our new office. So how do you go about doing this? You need to take a bunch of decisions to actually do the purchase. So we start with which website, which portal or which website you should use. So we try to find out, let's say you want to buy the furniture. Obviously, you don't go to a online grocery store because you need furniture, because there are several websites. So that is the first decision you need to take, which website I should use. So once we have multiple websites, you kind of discard all the websites which don't sell furniture and you stick to those websites which sell furniture. Now, within that, we try to find out what is the ratings of these websites. If the ratings is more, that means they are reliable, the quality probably is good, and so on and so forth. So only then you want to buy from that particular website. So anything that doesn't satisfy this criteria, you close all those websites. Close in the sense you close the browser, right? So you still are left with maybe a few of these which satisfy your criteria, that is, which sell web pages or websites that sell furniture. They have a rating of 4 and above, and then you look for discount. Is somebody providing discount greater than 20%? Then again, you filter out some of them which probably are not providing any discount, and 0 down to 1 or 2 websites which are probably providing those discounts, and go ahead and select the furniture and purchase it. So this is a very basic example. We probably don't follow this always exactly the same way, but just to illustrate, drive home the point. So we can answer a lot of questions using data science. For example, when we take a cab, when we book a cab, now to go from location A to location B, what is the best route that the cab can take to reach in the fastest way or in the least amount of time? There could be several factors. There could be traffic, there could be bad road, there could be weather. Now all these come as inputs, and a decision needs to be taken as to which is the best route. Another example is TV shows. So Netflix and maybe even a lot of other TV channels, they have to perform this analysis to find out what kind of shows people are viewing, what kind of shows people are liking, and so on and so forth, so that they can then sell this information to advertisers, because their main source of revenue is advertising. So this is again major function of data science. Predictive maintenance. We need to find out, will my car break down? Will my refrigerator break down in the next year or 2 years? Should I be prepared to buy a new refrigerator? You can potentially apply data science here as well. And then in politics, a lot of data science is applied in politics. You must have seen on TV about US elections, or in UK, or even in India. Nowadays, everybody is applying data science in elections and trying to capture the votes, or rather the voters, influence the voters, personalized messages, providing personalized messages, and so on and so forth. And that is one. Not only that, people use data science to even predict who is going to win the elections. It's a different matter that probably not all predictions come out to be true, but then yes, they use data science to do this predictions. So what is the process, or what are the various steps in data science? The first step is asking the right question and exploring the data. Basically, you want to know what exactly is the problem you're trying to solve. So that is asking the right question. So that is this circle out here. Then the next step is after exploring the data. So, as a first step, you will ask some questions. What exactly is the problem you're trying to solve? And then, obviously, you will have some data for that as input, and you perform some exploratory analysis on that data. For example, you need to clean the data to make sure everything is fine, and so on and so forth. So, all that is a part of exploratory analysis. And then you need to do the modeling. Let's say if you have to perform machine learning, you need to decide which algorithm to use and which model to use, and then you need to train the model and so on and so forth. So that's all part of the modeling process. And then you run your data through this model and then through this process, and then you come out with the final results of this exercise, which includes visualizing the results and preparing a way to communicate the results to the concerned people. So it could be in the form of PowerPoint slides, or it could be in the form of a dashboard, which is basically what we call as a visualization. And so all the insights that have been gathered through this exercise, that has to be communicated in a proper way, in an easy to understand way, which is again a key part of this whole exercise, communicating the results. So what are the prerequisites for data science? There are three essential traits required to be a data scientist. One is curiosity. You need to be able to ask questions. The first step in data science is asking questions. What is the problem we are trying to solve? If you ask the right question, only then you'll get the right answer. Very often, this is a very crucial step where a lot of data science projects fail because you may be asking the wrong question. And then obviously when you get the answer, that's not the answer you're looking for. So it is very important that you ask the right question. Needless to say, then the second part or the second trait is common sense. So you need to be creative. You need to come up with ways to use the data that you have and try to solve the business problem on hand. In many cases, you may not have all the data that you need. In many cases, the data may be incomplete. So that is where you need to come up with ways, what are the best ways to fill these gaps wherever this is missing. And that's where common sense comes into play. Last but not least, after doing all this analysis, if you're unable to communicate the results in the right way, the whole exercise will fail. So communication is a key trait for a data scientist. Maybe technically you may be a genius, but then if you are unable to communicate those results in a proper way, once again, that will not help. So these are the three main traits: curiosity, common sense, and communication skills. In a way, you can say these are the three C's. Okay, so what are the other prerequisites? The first one, so machine learning. Machine learning is the backbone of data science. Data science involves quite a bit of machine learning in addition to the basic statistics that we do. So a data scientist needs to have a good hang or need to be very good at data science. The second part is modeling. So modeling is also a part of machine learning in a way, but you need to be good at identifying what are the algorithms that are most suitable to solve a given problem, what models can we use, and how do we train these models, and so on and so forth. So that is the second component. Then statistics. Statistics is like the core foundation of data science. So you need to understand statistics and you need to have a good hang of statistics in order to be a good data scientist. And this will also help in getting good results. Programming is to some extent required. At least some program or the other would be required as a part of executing a data science project. The most common programming languages are Python and R. Python especially is becoming a very popular programming language in data science because of its ease of learning, because of the multiple libraries that it supports for performing data science and machine learning and so on. So Python is by far one of the most popular languages in data science. If any one of you is wanting to learn a new language, that should be Python. And then of course you need to understand databases, how databases work, and how to handle databases, how to get data out of databases, and so on. So these are some of the key components of data science. Now, coming to the tools and skills that are used in data science, these are some of the skills from a language perspective. It is Python, or R. And from a skills perspective, in addition to some of the programming languages, it would help if you have a good knowledge or good understanding of statistics. And what are the tools that are used in data analysis? SAS is one of the most popular tools. It's been there for a very long time, and that's the reason it is very popular. And however, this is compared to most of the other tools, it is a proprietary software, whereas Python and R are mostly open source. The other tools are like Jupyter Notebooks. You have RStudio. These are more development environments and development tools. So Jupyter Notebooks is a interactive development environment. Similarly, RStudio is for performing or writing R code and performing analytics and performing data analysis and machine learning activities you can perform in RStudio. It has a very nice UI, and initially R was not so popular primarily because it did not have user interface, and RStudio is a relatively new addition, and after the advent of RStudio, R became extremely popular. And there are other tools like MATLAB, and of course some people do with Excel as well. As far as data warehousing is concerned, some of the skills that are required are ETL. So in order to extract data and transform load, ETL stands for extract, transform, load. So you have data in the databases like your ERP system or a CRM system. You need to extract that and then do some transformations and then load it into your warehouse so that all the data from various sources looks uniform. Then you need some SQL skills, which is basically querying the data, writing SQL queries. Hadoop is another important skill, especially if you're handling large amounts of data. And also, one of the specialities of Hadoop is it can be used for handling unstructured data as well. So it can be used for large amounts of structured and unstructured data. Then Spark is an excellent computing engine for performing data analysis or machine learning in a distributed mode. So if you have a large amount of data, the combination of Spark and Hadoop can be extremely powerful. So you store your data in Hadoop HDFS and use Spark as your computation engine. It works in a distributed mode similar to Hadoop in like a cluster. So those are excellent skills for data warehousing. And there are some standard tools that are available like Informatica, DataStage, Talent, and also AWS Redshift if you want to do some on the cloud. I think AWS Redshift is again a good tool. Data visualization tools. For data visualization, some of the skills that would be required are, let's say, R. R provides some very good visualization capabilities, especially for developing during development. And then you have Python libraries, Matplotlib, and so on, which provides very powerful visualization capabilities. And that is from skills perspective. Whereas tools that can be used are Tableau is a very, very popular visualization tool. Again, that's a proprietary tool, so it's a little expensive maybe, but excellent capabilities from a visualization perspective. Then there are tools like Cognos, which is an IBM product which provides very good visualization capabilities as well. And then coming to the machine learning part of it, the skills required there are Python, which is more for programming part, and then you will need some mathematical skills like algebra, linear algebra especially, and then statistics and maybe a little bit of calculus and so on. And the tools that are used for machine learning are Spark MLlib and Apache Mahout. And on cloud, if you want to do something, you can use Microsoft Azure ML Studio as well. So these are by no means an exhaustive list. There are actually many, many tools and probably a few more skills also maybe there. But this gives a quick overview, like a summarization of the tools and skills. Now, moving on to the life of a data scientist. What does a data scientist do during the course of his work? So let's see. So typically, a data scientist is given a problem, a business problem that he needs to solve. And in order to do that, if you remember from the previous slide, he basically asks the question as to what is the problem that he needs to solve. So that is the first thing. He has got the problem. Then the next thing is to gather the data that is required to solve this problem. So he goes about looking for data from anywhere. It could be the enterprise. Very often the data is not provided in the nice format that he would like to have it or we would like to have it. So first step is to get whatever data that is possible, what is known as raw data in whatever format. So it could be enterprise data, it could be there is probably a requirement to go and get some public data in some cases. So all that raw data is collected and then that is processed and analyzed and prepared into a format in which it can be used, and then it is fed into the analytics system, be it a machine learning algorithm or a statistical model, and we get the output, and then he puts these output in a proper format for presenting it to the stakeholders and communicating those insights or the results to the stakeholders. So this is a very high level view of like a day in the life of a data scientist. So gathering data, raw data, performing some quick analysis on that, and maybe processing or manipulating this data to bring it into a certain good format so that it can be used for the analysis, feeding this into that analysis system that has been designed, be it mathematical models, machine learning models, and then get the results, the insights, and then present it in a nice way so that the stakeholders can understand. How about machine learning algorithms? So let's see what are the various machine learning algorithms that would be required for a data scientist. So these are a few of the algorithms. Again, there's not an exhaustive list. We have regression is one of the supervised learning models or techniques. So in case of regression, you try to, let's say, come up with a continuous number. So the difference between regression and let's say a classification is that in case of classification, those are discrete values. Whereas here we are talking about regression where let's say you are trying to predict the temperature, which is a continuous value, or the share price, which is a continuous value. So that is regression. So you need to know what is regression, how to perform regression, and we need to understand clustering. So clustering is one of the unsupervised learning techniques. In this case, there is no label data that is available, and you get some data and then you want to put this into some shape so that you can analyze it and you try to make sense out of it. Let's say you have, one example is you have a list of cricketers and they have not been marked as bowlers and batsmen or all-rounders or whatever, right? So you just have their names and maybe how many runs they scored, how many wickets they have taken, and so on. But there is no readily available information saying that, okay, this person is a batsman, this person is a bowler, and so on. So I'm talking about cricket. Hopefully, most of you are familiar with the game of cricket. So how do we find out? So then we put this into a clustering mechanism, and then the system will say that, okay, these are the people who have all scored good amount of runs. So they belong to one cluster. These are all the people who have taken good amount of wickets. So they belong to one cluster. And maybe here are some people who have taken good amount of wickets and they have made good amount of runs. So they may be belonging to one group. And then we take a look at it and then we label them as, okay, people who have all together and those who have, scored many runs, we label them as batsmen. People who have taken a lot of wickets, we label them as bowlers, and people who have taken good amount of wickets and also made some good runs, we label them as all-rounders. But the system will just say, okay, this is cluster 1, cluster 2, cluster 3. The names we human beings have to give the names. Now, decision tree is used for what is known as classification. Primarily, it can also be used for regression, but by and large, it is used for classification. And here again, it's a very logical way in which the algorithm goes about classifying the various inputs. One of the biggest advantages of decision tree is that it's very easy to understand and it's very easy to explain why a certain object has been classified in a certain way compared to maybe some of the other mechanisms like, say, support vector machines or logistic regression and so on. So that's the advantage of decision tree, but that is also a very popular algorithm. Then we have support vector machines primarily for classification purpose, and then we have naive Bayes. This is again a statistical probability based classification method. So these are a few algorithms. There are a few more that are not listed here, but there are some more algorithms as well. And by the way, there are detailed videos about each of these algorithms available. You can check in the playlist. So now let's talk about the life cycle of a data science project. Okay, the first step is the concept study. In this step, it involves understanding the business problem, asking questions, get a good understanding of the business model, meet up with all the stakeholders, understand what kind of data is available, and all that is a part of the first step. So here are a few examples. We want to see what are the various specifications, and then what is the end goal, what is the budget, is there an example of this kind of a problem that has been maybe solved earlier. So all this is a part of the concept study. And another example could be a very specific one to predict the price of a 1.35 carat diamond, and there may be relevant information inputs that are available, and we want to predict the price. The next step in this process is data preparation, data gathering and data preparation, also known as data munging, or sometimes it is also known as data manipulation. So what happens here is the raw data that is available may not be usable in its current format for various reasons. So that is why in this step, a data scientist would explore the data. He will take a look at some sample data, maybe pick, if there are millions of records, pick a few thousand records and see how the data is looking. Are there any gaps? Is the structure appropriate to be fed into the system? Are there some columns which are probably not adding value, may not be required for the analysis? Very often these are like names of the customers. They will probably not add any value or much value from an analysis perspective. The structure of the data, maybe the data is coming from multiple data sources and the structures may not be matching. What are the other problems? There may be gaps in the data. So the data, all the columns, all the cells are not filled. If you're talking about structured data, there are several blank records or blank columns. So if you use that data directly, you'll get errors or you'll get inaccurate results. So how do you either get rid of that data, or how do you fill these gaps with something meaningful? So all that is a part of data munging or data manipulation. So these are some additional subtopics within that. So data integration is one of them. If there are any conflicts in the data, data may be redundant. Yeah, data redundancy is another issue. There may be, you have, let's say, data coming from two different systems and both of them have customer table, for example, customer information. So when you merge them, there is a duplication issue. So how do we resolve that? So that is one. Data transformation. As I said, there will be situations where data is coming from multiple sources, and then when we merge them together, they may not be matching. So we need to do some transformations to make sure everything is similar. We may have to do some data reduction. If the data size is too big, you may have to come up with ways to reduce it meaningfully without losing information. Then data cleaning. So there will be either wrong values or null values, or there are missing values. So how do you handle all of that? A few examples of very specific stuff. So if there are missing values, how do you handle missing values or null values? Here in this particular slide, we are seeing three types of issues. One is missing value. Then you have null value. You see the difference between the two, right? So in the missing value, there is nothing, blank. Null value, it says null. Now the system cannot handle if there are null values. Similarly, there is improper data. So it's supposed to be numeric value, but there is a string or a non-numeric value. So how do we clean and prepare the data so that our system can work flawlessly? So there are multiple ways, and there is no one common way of doing this. It can vary from project to project. It can vary from what exactly is the problem we are trying to solve. It can vary from data scientist to data scientist, organization to organization. So these are like some standard practices people come up with. And of course, there will be a lot of trial and error. Somebody would have tried out something and it worked and will continue to use that mechanism. So that's how we need to take care of data cleaning. Now, what are the various ways of doing, if values are missing? How do you take care of that? Now, if the data is too large and only a few records have some missing values, then it is okay to just get rid of those entire rows, for example. So if you have 1,000,000 records and out of which 100 records don't have full data, so there are some missing values in about 100 records. So it's absolutely fine because it's a small percentage of the data. So you can get rid of the entire records which have missing values. But that's not a very common situation. Very often you will have multiple, or at least a large number of a data set. For example, out of 1,000,000 records, you may have 50,000 records which are like having missing values. Now that's a significant amount. You cannot get rid of all those records. Your analysis will be inaccurate. So how do you handle such situations? So there are again multiple ways of doing it. One is you can probably, if a particular values are missing in a particular column, you can probably take the mean value for that particular column and fill all the missing values with the mean value, so that first of all you don't get errors because of missing values, and second, you don't get results that are way off because these values are completely different from what is there. So that is one way. Then a few other could be either taking the median value or depending on what kind of data we are talking about. So something meaningful we will have put in there. If we are doing some machine learning activity, then obviously as a part of data preparation, you need to split the data into training and test data set. The reason being, if you try to test with a data set which the system has already seen as a part of training, then it will tend to give reasonably accurate results because it has already seen that data, and that is not a good measure of the accuracy of the system. So typically you take the entire data set, the input data set, and split it into two parts. And again, the ratio can vary from person to person, individual preferences. Some people like to split it into 50-50. Some people like it as 63.33 and 33.3 is basically 2/3 and 1/3. And some people do it as 80-20. 80 for training and 20 for testing. So you split the data, perform the training with the 80%, and then use the remaining 20% for testing. All right. So that is one more data preparation activity that needs to be done before you start analyzing or applying the data or putting the data through the model.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.